All right, let's talk about building AI agents that actually work. We're going to go way beyond the usual hype and get into the real secret sauce, the stuff that engineers in the trenches are figuring out right now. This is the good stuff. So, if you want to build a smarter AI, what's the first thing that pops into your head? Bigger models, right? More parameters, more power. And look, that's definitely part of the equation. But what if the real game changer, the thing that turns a clunky bot into a genuinely useful agent, has nothing to do with the model's size? What if it's all about what you feed it? And that's where this idea comes in, context engineering. It's the term the team at Manus uses, and it's brilliant. This isn't just about writing a better prompt. No, this is the deep, meticulous craft of designing the entire world an AI sees, moment to moment. It's how you guide it, how you shape its behavior, and how you unlock what it can really do. This right here is where the magic happens.
I absolutely love this analogy from Yichao Peak G at Manus. Think about it. New, better AI models are like a rising tide. They lift everything up. Now, if you build your agent like a pillar, fine-tuning it to one specific model, well, you're stuck to the seabed. When the tide rises, you're just a taller pillar. But if you master context engineering, you've built a boat. You're free. You can just ride that rising tide, swapping in the latest and greatest models as they come out without ever having to rebuild your whole operation from scratch.
Okay, so let's get practical. The first major hurdle every single agent builder hits is speed and cost. They're a nightmare. And the key to taming both of them is mastering a little something called the KV cache. You can basically think of it as the model's short-term memory. Now, to really understand why this is so critical, just look at this number. For a regular chatbot, your input and output are more or less the same size. But for an agent that's out there using tools, thinking, observing its environment, the input context just balloons. At Manus, their average input to output ratio is a wild 100 to 1. That's a huge amount of information to reprocess for every single tiny step the agent makes. And yeah, that hits you right in the wallet. This is where the KV cache saves you. If the beginning of that massive context is the same as it was on the last turn, it can be cached, which saves a ton of time and money. With a model like Claude Sonnet, we're talking about uncached tokens costing 10 times more than cached ones. That is not a small rounding error. 10 times. So getting this right isn't just some nice optimization. It's the difference between having a viable product and a project that's just way too expensive to run. So how do you get that sweet, sweet cache hit rate as high as possible? Well, Manus lays out 3 golden rules. First, you've got to keep your prompt prefix stable. Even a tiny change, like an updating timestamp, can wreck the whole thing. Second, your context should be append only. Just add new stuff to the end. And third, you might need to actually add explicit markers that tell the system, hey, cache everything before this point. These are simple rules, but they have a massive impact. All right, so we've covered speed and cost. But context engineering also helps agents just work, well, smarter, especially when they have a ton of tools to choose from. Imagine your agent has hundreds of possible actions. How on earth do you keep it from getting confused? So your first instinct might be to just remove the tools from the context that aren't relevant for this specific step. Makes sense, right? Well, it turns out that's a really bad idea. First, it changes the context, which breaks your KV cache. And second, it totally confuses the model when it looks back and sees itself using tools that have now magically disappeared. The expert move is way more clever. Keep all the tools in the context, but use something called logit masking. It's like programmatically telling the model, look, I know you see all these tools, but you are forbidden from picking these specific ones right now. It's elegant and it works. Now we're getting to the really mind-bending part. The next few insights from the Manus team kind of fly in the face of conventional wisdom. These are those hard-won, counterintuitive truths you can only figure out after you've seen agents succeed and fail millions of times in the real world. Okay, so even with these giant new context windows, agents still run out of room. The contents of a web page or a big document can eat up tokens like crazy. The Manus solution is a total shift in thinking. Stop seeing the context window as the agent's only memory. Instead, teach the agent to use the file system. It can write observations to a file, drop that text from its immediate context to save space, and then just read the file later if it needs that info again. Suddenly, the file system becomes its true unlimited long-term memory. Okay, this next trick is just genius. You might see a Manus agent creating a file called todo.md and think, oh, that's cute, it's organizing itself. But it's so much more than that. It's a deliberate attention hack.
By constantly rewriting its own to-do list and sticking it at the very end of the context, the agent is essentially whispering its main goals to itself, over and over. This forces the most important information, the actual objective, into the model's most recent attention, so it doesn't get lost or distracted in the middle of a super long task. Here's another one of those powerful, counterintuitive truths. When your agent makes a mistake, calls the wrong tool, gets an error, what's your gut reaction? It's to hide it, right? Clean up the log, try again, and just pretend it never happened. But as this quote points out, when you erase the failure, you remove the evidence. And without evidence, how can the model possibly learn? So the key is to do the opposite. You have to leave those errors in the context. Let the model see what went wrong. By seeing its own mistakes, it gets to update its internal beliefs. It learns, okay, that approach didn't work, so I'm less likely to try that specific thing again. This is how you build true error recovery, which, let's be honest, is one of the clearest signs of real agentic intelligence.
So let's just zoom out for a minute. When you put all these little pieces together, what do you have? It's not just a collection of clever tricks. It's a whole philosophy for how we should be thinking about building the next generation of AI agents.
The team has this fantastic, kind of nerdy name for this whole process: stochastic graduate descent. It's a little joke, a play on the machine learning term stochastic gradient descent, but it perfectly captures the reality of building agents right now. It's a manual, hands-on, experimental science. It's about fiddling with prompts, trying different architectures, and just learning from what actually works in the wild. So let's boil it all down. What are the key lessons here? First, the KV cache is king. Design everything around it to control your speed and cost. Second, mask your tools, don't just delete them. Third, think of the file system as your agent's real memory. Fourth, use recitation tricks to keep your agent focused. Fifth, let your agent see its failures so it can actually learn. And finally, you have to introduce diversity in its tasks so it doesn't just get stuck in a rut, mimicking its own patterns. And that leaves us with this final thought. The future of truly useful AI isn't just going to magically appear with the next big model release. It's going to be built, carefully and deliberately, one context at a time. The real challenge and the real opportunity is right there in engineering them well. Thanks for tuning in.